So in today's session, we will actually look into a program, right? So we had seen what kind of programs that we are going to have, and we're going to look into the software as to how we are going to run the program, okay? And I hope all of you have installed the software on your computers, right? Okay.
Sir,
So
we have downloaded from Google Drive, but we have problem installing it.
you have problem in installing. There are two files actually, right? So
Yes, sir.
only those two files you need to install, and this will even support your 32-bit processors. It's not very high demanding software, okay? Even on 32-bit processors also it does, which means it supports on anything, so it shouldn't be a problem.
After finishing, it's showing the release notes, sir, in Google.
Ah,
App is not installed, sir, but it's after completing all the process, it shows the release notes. That's it's not getting installed, sir.
it's not getting installed. Okay, no problem. I will send you a link again, okay, in
Yes.
which I have saved the file. So you can probably try doing it in that, okay? And we'll see what happens,
Okay, sir.
right? Fine. So the first thing that we are going to look into today is program involving general data processing instructions. So when we talk about data processing, okay, so this plays a very important role, okay, because we are these days playing with only data, right? When I say data, it can be numbers, it can be information, right? And ultimately this leads to something called communication, right? So the first thing that we're going to look into here is data processing instructions, right? So to write an assembly language program for adding two 32-bit numbers, okay? So we are doing a normal simple uh, addition program, okay? And we're going to look into it as to how this happens. So we are going to use KEIL Microvision 5, or even 4 is also good. But I suggest that you use 5, okay? As mentioned, I'll be sending you the link again, wherein you can try downloading and you can run the file, okay? Right. So you are initializing this area, okay? And you are giving the name of the program, okay? And then you're telling you're going to read it, okay? And code and read only. So going to start the program, okay? So these are your labels, right? These are your labels. So we are giving two values here, okay? LDR is nothing but your load resistor, R naught with data 10. And one thing you should keep in mind here is, the data processing happens all in hex, okay? In hex format. And your R1 is also loaded, okay, with data 20. So the meaning of this is that, okay, it's going to add R1, contents of R1 and contents of R0. So these becomes the source, and whatever is, the result is saved in R2, right? Simple, right? Isn't it? Yes or no?
Sir.
Yeah. So data we are giving 10 here, and then another data we are giving, this is direct addressing mode, right? We are just giving data to the register, right? We are just saving these numbers, and then we are trying to add those data, right? How are we adding? R1 and R0 is added, okay? And whatever result is there, okay, that is actually pushed to R2, okay? So ultimately you should be able to see your result in R2. So if we see here, okay, 10, 20 is 1, 4. Then once I add them both, okay, you can do a normal decimal addition, and then convert it to hex. So you should be getting 1E as your result. Okay, so you will be finding this in R0 as well as in R2, right? I think this should be R2, right? So we will check and we will see as to how this program runs. Okay, let me just I'll just share you the screen. Okay, so that will be easy for us to. Right. So the first thing that you are going to do here is let me just close everything. So you're going to click on project, okay, and then you will find an option called new microvision project. Okay, so you should click on that. So once you click on that, you will get create a new project wizard, and it will ask you what file name that you want to give. Okay, so I will just randomly give it as 12. Okay, you can name it as probably add or anything. Yeah, let's put it as add. I'm not giving it as add because it could be the keyword. Okay, it is the keyword, so I'll just give it as add 1, and then I click on save. Okay, so here under device, okay, should click on legacy device database. Okay, then here you should search for ST microelectronics. Okay, so code is STM32 F401. This is what I want, RE. Okay, so please make note of this. This is important. STM32 F401 RE. So we are going to use this processor. Okay, so it is 32-bit M4 Cortex. Okay, and then it has about 84 megahertz of maximum frequency. Okay, it has DSP instructions, MPU, which is memory protection unit, and the memory, or the flash memory is about 512 kbps, kilobytes, and the other specifications can be seen here, like crystal oscillators. Okay, and the oscillator for then you can see 2.4, the converter, up to how many channels. So whole set of information, how many USBs, USARTs. Okay, all this information can be seen. Okay, you can click OK. So this will ask you if you need this startup file to your project. You should click on yes. Okay, so once you click on yes, this is what you're going to see in your left hand side. Okay, you'll have project, add 1. Under that you'll have target, and then you will have source group 1. Below source group 1 you will have this startup file. Okay, you will have this startup file. Now you don't have to worry about this startup file. Click on this button here, or you can even click on file new. Okay, So here, this is the area where you are going to type your code. Okay, fine. So I will just take the code. Right? Now you have to save it. Okay. Now for saving it, you have to save it as .s. Right. So I'll be giving it as 1.s. Now you see this text, okay, it's all in monocolor, right? And once you save it, it all becomes colored, okay? So you can see that, these changes have happened, okay? Just make sure that, this should start here, okay? So use a tab, okay? Spacing is very important here, okay? Click on save. There are some changes that has to be done, okay? So I will let you know. Now, left click here, click on add existing files to group source group 1. So you have to select this. And then once you go here, okay, this was add 1, right? So you have to just add 1.s. So take that file, okay, and you can click on add. See, as soon as you click on add, it comes here. Okay, fine. So now you have to check for errors. Okay, so you have an option called translate. Okay, so you get 0 errors, 0 warnings. Okay, let us try to make some error. Let us just put it here, save it. Okay, and then see, we get 2 errors, right? And that error was specifically because of the spacing, right? So you can say, see here, the area directive is missing. Okay, unknown opcode. Okay, it's a fake area. Okay, so all these is referring to the spacing here, right? Save it. Translate. The short is Control F7. Okay. So after translating, okay, next you have the option to build. Okay, so click on build. It will take some time. Okay, you can see all this happening here. It will tell you, how much of time that it has taken. Okay, uh, here it says target not created because of the error. Okay, so which means these changes are not getting reflected, whatever changes were there previously. Okay, so that is fine. Then objects add one target not created, not enough information to list symbols, unidentified symbol main. Yeah. Now this error is because, now I will tell you, what you have to do is, you have something here called starter. Okay. Here also you have start. Now remember I had told you about this startup file, right? So open that startup file. You have to comment a few things. Okay. 180, you have to comment. Okay. Comment here is semicolon. You can see that the color changes, right? As soon as you put a semicolon, okay, the color changes. The next is 183. Here also you have to comment. Okay, it becomes grayed out. And 184. Okay. Now the other thing that you have to do here is, okay, as I told you, here you have start, right? but then here you have underscore underscore main, so you have to replace it. Okay, replace it with start, which is in your code. Fine. So I have replaced it in line 181 and I've replaced it in line 185, right? So you will get this kind of error, right, where it says unidentified symbol main. Okay, so we had underscore underscore main, isn't it? So this is the error that it is showing us, right? So I have replaced with start, right? And then now you can save this file, okay, the startup file. So now what should we do now? We have to again translate it. Okay, so I have 0 errors, 0 warnings, which is good. And then now I can click on build. Okay, so it says it has taken about 1 second. Okay, 0 errors, 0 warnings. Okay, and it has created, right? The next thing that you can do is you have an option called debug. Okay, so press this start or stop debug session. So it will give you a small warning window, okay, stating that it's in evaluation mode. Press OK. So now it actually gets into your execution mode. Okay, so now you can see here, okay, either step by step you can execute, or you can just execute it one shot. Okay, so if you want step by step, then it is F11. Okay, so let us do it F11, and I want you to concentrate here also and see as to how this code is running. Okay, so I press F11 once. So R0 is getting its data. Okay, let me show this code. Yeah, so R0 is going to get the data, right? So R0 is going to get about 10.08. So this is my R0 register, and the value is 0.810. Right? You can see the green line here, right? So this green line is referring to next instruction that is going to get executed. Right? So 20, okay, that is 14 is getting transferred to R1. The next instruction here is add, right? Add R1, R2, and result should be in R2. So this 1E, right? 1E is actually there. Again, click on F11. It shows me that it has stopped. Okay, so which means it has ended the execution. One more thing that you can also see here is when you just place your mouse on this, okay, it will show you that it has the value 0A, and then here it has the value 14, then here it has the value 1E. Okay, here it has the value 0A, here 14, right? So these two data are added and it is sent to R2. Fine. So this is the way in which you can actually check for your answers. Okay, and this is the register bank that you can see. So there are a lot of instruction sets available with your ARM processor. Okay, this R0 to R12, okay, is the mostly used for registers. R0 to R12. From R0 to R7 that you can see, these are lower registers, and R8 to R12 are higher registers. Then this 13, 14, 15, which is stack pointer, okay, link register, and PC, your program counter, okay. These are all special purpose registers. Okay, so this is about it. So still you are in execution mode. right? So what you have to do, you have to click on debug and stop debug execution. Okay. So it will return back to our normal editing mode. It is not in execution mode, it is in editing mode now. So as I was mentioning, there are about 185 instruction sets, okay, for ARM Cortex processors. Okay. So as I was telling you, this is going to be the source, right? And this is going to be the destination. Okay, so it's destination comma source. Okay. So this is going to be treated as first register, second register, and then the final destination register. Right? So I hope all of you have understood the way in which we have simulated the programs. Meanwhile, okay, similarly, it's going to be the same way, okay, in which you are going to execute the programs. So you can even write an algorithm for this, right? So we are initializing the code area, then link the program code to the processor. That one was done using startup file, right? And then we are loading the value R1 and R0, and then we are adding the values, storing the result in R2, and then the end of the program, right? So students, any doubts with the one that we have discussed so far?
Sir, why we have written start to start to?
Sorry,
Where we have written start B start with the program.
stop.
Start B.
Yeah. So this is for ending the loop. Okay. So it is just that it is going to stop here. So after adding, okay, we're just going to stop the branch. Okay. Stop the execution of the branch, and then this is going to end our program. Very simple programs. Okay. And you can actually write larger programs when compared to this. Okay. So as mentioned, I'll be sharing you the link. Okay. And you can download it, and if any issues or any concerns, you can always feel free to get back, and I will try to sort it out. Okay.